Happy Thursday. Huge news today. It is the 18th of April, 2024, and Meta, formerly known as Facebook, just released LLaMA 3. So large language model Meta AI, the little A in the middle is silent. This is their most advanced model, because we had, LLaMA 2, that was about like a few months ago, and then LLaMA before that, but this is the third iteration of that. And so we're seeing here is their blog post about it, introducing Meta LLaMA 3, most capable openly available LLM to date. So just briefly going through here, right? And it's going to be released towards AWS, and Amazon Web Services, Databricks, Google Cloud, Huggingface, Kaggle, these being all places that you'll be able to get access to it, as well as having that support from depending on if you are looking for more of those enterprise use cases. So, and the fact, really great that they have all of these cybersecurity tools. So LLaMA Guard being from like their Purple Llama work, Code Shield, and CyberSec Eval 2. So this really being some of the things that the National Institute for Standards of Technology, or NIST, has been on the forefront of and working hand in hand with Meta towards. So we're seeing, right, as they're talking about new capabilities, longer context windows, so that means more text or more input in and out, additional model sizes. So currently, let's see, I think it's 8 billion and 70 billion parameters. And anytime you're hearing parameters, really it's, what's a good way of putting it? Think of as in the possible connections that it could end up making. Like for contrast, I think, what is it? Crow has like 2 to 3, was it million or billion? Think of just the possible connections or possible topics that could end up being connected with. When you hear all, and it doesn't, I know it sounds like a super huge number, but still it's less about getting the most parameters possible and more about aligning parameter size with domain knowledge with the use cases. The more you're able to do that, the more you can have a smaller model to be able to use less energy. It's great to have a big model to be able to do those big things and really to push forward a lot of very big tasks, but there is just that cognizance around how much energy is required. So, right, because the bigger the model, more memory, just the more energy. It's just how the math works out. Anyways, okay, so 8 billion, 70 billion parameters, broad use cases, steady performance, improved reasoning, best approaches, kickstart next wave, innovation, absolutely. And right, by giving it to the open source community, I mean, that's really how LLaMA got as good as it did, LLaMA 2, and really it's just people able to see something for what it is and just build with it. So let's see here. Text-based model releasing today is the first, so it's really a collection to come forward. So definitely look at me seeing multilingual, which, right, that's great. What is the purpose of AI other than to help us connect better as people? And multimodal, so meaning that it won't just be text in, text out, but it could be text in, video out, video in, text out. So just think of modality as like categories of data. And so if it's multimodal, that means that it can be able to handle multiple different data types, input and output. And continue to improve overall performance, reasoning, coding. So let's see, major leap, improvement, retraining, instruction fine-tune. So instruction fine-tune, that is a certain kind of fine-tuning, being that you are giving it those, basically, hey, when this is occurring, do this at a very high level. Because we're finding that reinforcement learning with human feedback, that is a very broad way of describing training and fine-tuning. Then really we're finding that the more specific we can be with the way that we're giving that fine-tuning, versus just here's a bunch of data with a bunch of textbooks or a bunch of movies, just ingest it and just continuously go through the cycle. We find that if we're thoughtful and giving more of these preferences, or hey, in these situations this is the best thing, that we can get more nuance with the model in adjustment of the weights and the connections between the parameters. Not necessarily just, okay, every time cat picture is seen that it equals these things, but more given that instruction of when a cat is, with other cats, then they are what's the goodest comparison of that? Honestly, God, I can't think of anything. It's just, I'm just super excited, super stoked to be seeing this. So it's just like, but at the same time, it's, right, so maybe a good way of putting it is, you would not give the same advice to a 5-year-old that you would to a 10-year-old, that you would to a 20-year-old, that you would to a 30-year-old towards the question of what do you want to be when you grow up. So too, then across the different domains, it is important that we are mindful in our tuning to accommodate the different nuance of things. It's less of a one-size-fits-all and more of giving examples of what are appropriate things given the context of a situation. So let's see, and these here, what you can see are left to right, top to bottom. These are different benchmarks that you'll see, particularly on the Open Large Language Model leaderboard on Hugging Face. Feels weird still to say Hugging Face as a company, but they're crushing it. So Hugging Face, and of course they compared it with LLaMA 7B. So that is the IT being instruction tuned. That is the open source version of Google's Gemini, a proprietary Gemini model, and then you have Mistral 7 billion, so 7B instruct. Then you have the 70B, so 70 billion parameter here, compared with Gemini Pro 1.5, and then Claude 3 Sonnet. And so I think that's about the medium size of the Claude models from Anthropic. So it goes Claude 3 Haiku, and then Sonnet, and then Opus for the size. So let's see, we looked at model performance, we saw the optimized performance of real-world scenarios, right? And that is fed by human expertise in the different domains. And we developed a new high-quality human evaluation set. 800 prompts, 12 key use cases, ask for advice, brainstorming, classification, yep, reasoning, rewriting, summarization, which are that's generalizable to anything effectively. Yep. So Meta 3, human eval, aggregated, Mr. Medium. So again, largely it's, when you think of small models, think of below 7 billion, so more like the 1 to 3 billion, so that'd be like Phi 2, Tiny Llama, Tiny Dolphin, things like that, medium size, and you could say up to 7 billion, 8 billion. I would say that's my personal opinion, that is the high end of small. But then once you get the medium-sized models, that's more your 70 billion, 80 billion parameter models, and then large, which again, billion is a larger number, so they're technically all large. But that's where you get into like those mixture of experts models that would be the 8 times 22B, so 8 times 22 billion parameter models that have been mixed together. So what is 8 times 22? What, 164? Sure. To be able to have that domain expertise be implemented with 8 different experts combined, 8 different expert AI models that gain domain expertise or train in specific domains and then know to answer a question that is specific to that domain. So to develop a great language model, we believe it's important to innovate, scale, optimize, simplicity. Yes, absolutely, simplicity. But granted, to be simple, you have to have a deep understanding of something. Just like Dr. Feynman would talk about, world famous physicist who really pushed the bounds on quantum physics. It's the Feynman technique of being able to teach something to the level that a 5-year-old or someone who's a child. And it's not about intelligence, it's about the ability to, it is important to be able to explain something in a way that is understandable and accurate, and finding that bridge where we can err a little bit on accuracy if we are able to get better understanding, because you can continue to push towards full accuracy, but it's getting that initial, like, this is relatively equal to this. So anytime someone is saying explain like in 5, that really is the Feynman technique at play. So model architecture, it's a relatively standard decoder-only transformer architecture in LLaMA 3. That's fair. Compare LLaMA 2, made several key improvements. Tokenizer vocabulary 128. So that's tokenizer, so that's taking like the individual, when we type a prompt into, say, ChatGPT, for example, that when you say tokenizer, that is turning those words into a numerical representation. So in the same way that let's say you go to Chuck E. Cheese, I'm dating myself here, you give your real money to the machine, and it tokenizes it into things, or into those little individual Chuck E. Cheese tokens that have value to the machines at the Chuck E. Cheese place. Right? You can't just, it's been a while since I've been there, but you don't just put $5 directly into a Chuck E. Cheese, whatever the video game or the prize thing to get the tickets. You have to first tokenize, so take your input, which is money, turn it into something that the systems there understand, being the Chuck E. Cheese tokens, that then ends up giving output based off of what they're intended to do, whether it's turning the game on or whatever else. But so we think of your tokenizer, that really is that. So vocabulary of 228,000 tokens. So in the tokens, it's based off of the context, and so like the word relationship, like I did in a previous video, that based off of the context, the other words around it, that may be a different token than, say, earlier on, even though it's the same word, with what's called the self-attention mechanism of these transformer models, like LLaMA 3, that's the T in GPT, so all the GPTs, all the copilots that Microsoft makes, they're all effectively based off of transformers, and now we're starting to see the transformers being mixed with different models, like diffusion models for images and video, like Sora from OpenAI, and with other models like the recurrent neural networks. But that's still very much, that's something that's on like bleeding edge. Not something that I'm super knowledgeable on, but definitely starting to jump into, because we're seeing not just, because typically you can only mix models and modalities of the same class, the same variety. It's not like you can just say, oh, I'm going to mix this 80 billion parameter model with a 1 billion, like a Phi 2 from Microsoft with a LLaMA 3 from Meta, or at least to my knowledge, that is not the case. But so the fact that people now are able to mix these different models, like transformers and diffusion, to be able to get all the benefits of the self-attention to understand from context, and be able to produce, like we've seen those amazing AI videos that are like a minute long and actually understand the way the world works with Sora from OpenAI, is just mind-boggling. So let's see, temperature inference efficiency. So inference being you input text and then it outputs. So it's not, that's separate from the training. We train the models on sequences of 8,192 tokens using a mask to ensure self-attention does not cross document boundaries. All right, that's fair. So train the best language model curation of a large, high-quality training data set is paramount. Yes, in line with so when we talk quality, it's, I would say n of 1, but really it's not. When we think of quality, it is really 3 things. So 1, is it correct, which is that's a whole other ball of wax by itself. But big hand, small map. It's you want to have as many specific things, objective things that can clearly be seen as this is most correct, sometimes correct, not correct, or mostly not correct. The more we can give those objective things, the more we can have better predictability to what a model may do. Second being, what is the commonality? So, right, in medicine they say common things are common. So it's less about, we have to have the most recent this publication here, we need these textbooks. It's more on what are things that are going to be broadly used and are broadly known, because that way people can feel comfortable with being able to, and really those are going to be the questions people end up asking. They're going to ask them about things that they know and that they're going to interact with. And third being, is the data set aligned, particularly if it's a training data set. So if a training data set, which that's what this is it aligned to the training protocol? So if you are going to be doing something like direct preference optimization, or DPO, or you have to then put it into these pairs of this is yes, this is correct, this is not correct. If it's more just you're trying to just standardize RLHF, reinforced learning with human feedback, it may just be more you're just turning all the information into like taking PDFs and just pumping it through, which if you're not trying to have that level of specificity of the very nuanced, that can be okay. If it's more of just, hey, I want to have my repository of things, these are all of my data, this is all the data that I have, and I just want it to be input of what is this thing that I wrote that you have now ingested. That's all fine and great, but it's about aligning with what you expect it to be doing. I think there's a lot of merit in that, more so the things like the direct preference optimization, the instruction tuning. With that, it's also that responsibility of you, or anybody who is going to be training it, to then have the wherewithal of saying, this is correct, this is moderately correct, mostly incorrect, completely incorrect. And that is a big responsibility, because that is you, any individual, any group, then that setting that standard across the board of, we think X is good, we think Y is bad, and leave it at that. So, but given the amount of thoughtfulness and really what is at stake, I have every confidence that Meta has done the work to be able to align these things. And it's not about, big tech this and government that. It's about this technology being bigger than anything that we've ever seen before, and wanting to get it right for everybody, so that everybody can really make this shift towards this brighter future that we're all seeing. So yes, we don't think of social media as being super great, and there's a lot of things we're still figuring out, and there's not to say that we won't have missteps with this, with LLaMA 3 or any of these AI things, but it's more about, okay, let's all come together and let's all figure this out together, versus seeing this as just another fad or another craze. Tangent there, but just it's definitely at the forefront of my mind to be very mindful on what is being communicated about, what constitutes quality when we think of training data and really building AI. After a certain point, the number of GPUs is it's important. It's not going to be important, but or LPUs, or whatever PU, the processing unit. But it really is more about how do we go about, what are the benchmarks, what are the things that we say are really represent the best of us, and we acknowledge, but we mitigate the worst of us. So prepare for upcoming multilingual use cases. 5% pre-trained data set consists of high-quality non-English data that covers over 30 languages. And my own opinion would be that what is considered high-quality non-English data likely being, again, from those reputable sources and from things that are common, that are ubiquitous, so that aligning those two things. So shared LLama3 is trained on data with the highest quality, built serious data filtering pipelines, heuristic filters, NSF not safe for work filters, semantic deduplication approaches, and text classifiers to predict data quality. Okay, fair. Found that previous generations of LLama are surprisingly good at identifying high quality data. Fair. Hence we use LLama 2 to generate the trained data for text quality classifiers that are powered LLama 3. I mean, that makes sense. The self-play that we see, right, everything from AlphaGo that got iteratively better to what we see with, coming out of the woodwork, Amy from Google on that self-play mechanism, again, just going through again and again and again, iterating that synthetic data to build continuously better models. Yeah, makes sense. So scaling up pre-training. Effectively leverage our pre-trained data into LLama3 models. We put substantial effort into scaling up pre-training. Success. Specifically, we have developed a series of detailed scaling laws for downstream benchmark evaluations. These scaling laws enable us to select an optimal data mix and make informed decisions on how to best use our training compute. Because again, remember, Meta has at least about approximately 300,000, so that's 300,000 H100 equivalent processors for their training. So it's a lot. Civil observation, scaling, chinchilla, optimal amount of training compute, 200 billion tokens. That's actually way small because all things considered, 8 billion. Okay, 15 trillion being tokens, so 15T. That makes sense. That's a lot. So large models manage performance. Small models with less training compute. Small models are going to prefer because they're much more efficient during inference. Yes, 100%. Let's see, data parallelization and model parallelization, pipeline parallelization. So you take a model and divide it up and then run it in parallel. 24,000 GPU cores. It doesn't even real. It doesn't even like that. That's ridiculous. But also, at a certain point, it's more about, okay, how can we, once they are doing the heavy lifting with training all those things and getting the initial set, and then send it up to the community for the fine tuning to actually validate. So supervise. Instruction fine tuning, supervised fine tuning, SFT, rejection sampling, proximal policy optimization, PPO, and direct policy optimization. Oh, so apologies, must have gotten it. Got my wires crossed. Direct policy optimization, unless there's a difference in that. But point being that there still are it's much less about just RLHF anymore at this point. Reasoning, building with Llama 3. Torch tune. Oh, interesting. Say PyTorch, right? And again, that comes from Meta, so it's not really surprised that the PyTorch is crushing it. Because, it's what they know. System approach. Okay. Sorry, and I'm just going through here because, honestly, my hearing aid's running out of battery, so I'm trying to be a little bit quicker here. Let's see. Thanks for Llama 3. Woo! 400 billion parameters. That is intense. All right. And then you got this there. And so, this is ai.meta.com and the blog here. And, of course, no surprise, Ollama has already got Llama 3 on there. And actually, that's what we're seeing right here. That's what I've got pulled up. So, tell me the treatment options for fatty liver disease. Again, this is not anything that's been fine-tuned. This is purely just Llama 3 out of the box. So it's thinking about it. That's clipping along pretty good. And I know that people say, oh, but what if it hallucinates? And what if? And yes, any model can hallucinate, which is just it is making it's inferring based off the data that it's been given. But that's where we end up having retrieval augmented generation, RAG, with pointing a model, pairing up with trusted data sources, and implementing it in such a way that it can be able to actually have grounded sources of truth. Now, the interesting thing noticing, though, is that LLaMA 3, at least this smaller version, what we call it being quantized, so quantization here. Again, LL3, the license, is that it is just continuously going, which immediately makes me think of the self-play, of the fact that it's just continuously kind of iterating. So, and again, right, it's not going necessarily into something that is completely off topic, but it is just more continuing to go through here. So, but again, this is one version of it that has been quantized, put onto Ollama, so I did not, and fine-tuning it, and I have no doubt that it's more, though, something that is one small bug that will get itself worked out. I'll definitely be doing a much deeper dive onto this, being able to get it myself, the full model, fine-tune it, and be able to deploy it for a plethora of use cases. But just super excited, though, to be able to see even just the speed. Okay, all right, come here, you. All right, come here. Yeah. Interesting. So yeah, and again, like, no, this is not a hit. This is not but really seeing just the very interesting real-time paradigm of how it was trained and some of the outputs for it. Because again, none of it is like, oh, like, let me say all these things that are just blatantly wrong or terrible. It's always been about very positive, very like, okay, hey, let's make sure we're helping and being an aid and amplifying, versus just, oh, let me tell you how to make, napalm and all these other things. And so, right, being able to see this as well. So what are the treatment options for, let's see, the common cold. And this being just one of the UIs testing out here currently, with the different possible options, because it's familiar, and with the using for generative AI microservices. So a little bit slower, right? But then at the same time, it has more of that user-friendly experience. So, and this really, it's about helping people feel comfortable with when they're using things. So I will give it a go ahead and pause in terms of this, because I've gone way over time, but just really excited, and I think this is going to be like just amazing. And I'm really glad to be able to see this and see it's been open sourced, and that people will just be able to build really great things. And I'm planning on building a ton of stuff with this, so super duper excited. And I mean, just to feel how bright the future is, how amazing these things are going to be, and really just to see people come together and move towards a brighter, better tomorrow. I mean, it just, like, you just feel the energy, feel just really the how bright the future is, how amazing things are going to be, and I can't wait. It's a highlight of my week here. So hopefully this was helpful, and yeah, be sure to, I got to do the YouTuber thing, like and subscribe, and I will see you in the next one.